Now, yesterday we started talking about recursion, and we said recursion, or actually recursive methods, means that a method calls itself in order to solve a certain problem. Okay, and we need to learn how to think recursively by trying to divide the problem into simpler problems. Okay, and here in the PowerPoint they have mentioned a very nice thing. When thinking recursively, you have to find solutions to the simplest inputs. So, for instance, this sentence is very important when thinking about recursive methods. It's to find solution by looking or searching for the simplest input. So, for instance, in the triangle example that we have studied yesterday, the simplest example was that the square area was equal to 1. Okay, and we know that the area of one square is equal to 1, so we kept calling the method that is called get area of the triangle until we reach the value of 1. Once we reach the value of 1, we keep accumulating the ones of all squares in the triangle. The same thing happened in the Fibonacci series, if you remember. In the Fibonacci series, we know that a simple rule is that the Fibonacci of 1 is equal to 1. The Fibonacci of 2 is equal to again 1. So we created a method called fib, which calculates the Fibonacci of any integer number, and the method kept calling itself until we reach the value of 1 in case it is 2 or in case it is 1. Okay. I will repeat with you now very briefly the Fibonacci because I need to talk about it and so into more details. Here we go. I will open my Eclipse now. Okay. I have created a class called recursive fib. Okay. This is again explained also in your chapter. And the idea of this class is that I will give it a set of numbers, and I need the Fibonacci result of all these numbers. Okay, so this is how it looks like here. The Fibonacci result 4, so I'll say, for instance, the first 6 numbers. So it will give me the Fibonacci of 1 is equal to 1, the Fibonacci of 2 is equal to 1, etc. until I reach the Fibonacci of 6. So this is how the program is functioning. Okay, how do we do that? First, I will create a class called recursive fib. I will not write the code, I will just revise with you just to save our time. Okay, in this class I will have a main method where I can run my class. Then the first thing that I need to ask the user for is to enter how many numbers he wants the Fibonacci result for. So in order to allow the user to enter any input, we use the class scanner that is stored in the Java library system. Okay. In order to use the scanner class, I need first to import it. So import java.util.scanner. This means that the scanner class exists in the library that is called java.util. Okay. Once I import it, now I can create an object of scanner and I can start using it. So scanner in is an object of scanner. New scanner, I'm creating an object of scanner. Okay, and it takes an argument. This is the default argument that we write here, system.in. It means that there is an input that the scanner is taking here input. Okay, then I need to print a message for the user to tell him or to notify him that he needs to enter a value. So I will just say system.out.print enter n. Okay, now view once the n once the user enter a value, okay, this value has to be stored into a variable. Now, who will actually receive this value? You remember, I have now an object called in of type scanner. The scanner will read any value that is written on the console which the user will enter. So in, and I'm asking the user to enter integer number. So the in object has many methods for reading numbers. So it's in dot next int, so it can read the next integer that will be entered on the screen. It can read a byte, it can read short, it can read also string. Okay, so it can read anything. Next double, here we go. So it can read anything that I can specify here. In my case, it will be just an integer number, one integer number that will be entered by the user. If the user will be entering more than one number, so then I will say int, for instance, 2, and 2 equals, again, in dot next int, okay? But in my case, the user will enter just one number. Then, here, the user asked me to get the Fibonacci, okay, result of the first 6 numbers, as I did here in my example. Enter n equals 6, and then the result is here. So what do we do then? I will make a for loop, okay, and in each loop and in each iteration, I will call the fib method that is declared here below. We'll go, we'll revise the fib method right away, but I'm just so far explaining how the input is entered into the program. So n represents here the number, the number of values for which the user wants a Fibonacci result. So int I equals 1, I less than or equal n, and I plus plus. Okay, and then for each I, for instance, the first time I is equal to 1, so please call a method that is called fib and pass the value of I. In the first time it's 1. Then I is incremented by 1, so I is now equal to 2. So again, we call the fib 2. Now once I call the fib method, which we have explained yesterday, and I'm revising it now again. Once I call the fib method, it returns a value, an integer value, that is stored in a variable called f. Okay. Why f is declared as long? Because the Fibonacci result of a very large number can be also very large numbers. So in order to make sure that we can store this number, the whole number, we define it as long. Long has a larger space in memory than integer. Okay. Once I get the value, I will write, or I will print on the system.out.println the result. The fib of I is equal to f. Fib of I between bracket here, then I open bracket between quotations, and then the I value, and then is equal, and then close the brackets again, plus f, which is the Fibonacci result. Okay. So far, everyone's following. Okay, perfect. Now I need to see where my fib method is. Now, the fib method actually is declared in the same class. Yesterday, when we wanted to test it, for instance, the triangle, I have made 2 classes. One where we have declared my triangle class and the getArea method, and another called the triangle test, where we had a main method and we created an object of the triangle, and then we called the getArea. In my case here, I will declare everything in the same class. Can we declare it in 2 different classes? Yes, of course. Okay, so it's up to you. Now here, I will after the main method. I cannot remember the main method is a method, so I cannot declare another method inside a method. So if I want to declare another method, it has to be outside the main method, but in which class? Again, in the same class, which is called recursive fib. Now please note the following. I know you might be already knowing this information, but I'm just revising it. If I am declaring a method inside a class that has a main method, again, if I am declaring any method inside a class that already has a main method, and I am intending to call this method from within the main method, and I am intending to call this method or to use this method from within the main method, then this method has to be declared as static. Why? Because my main method is static, so I cannot call any other method except in only one case, if this method is declared as static. So I'm calling here the method fib, and where is the fib declared? It is declared in the same class, so I can just call it directly, but it has to be declared as static. You see, if I remove this keyword static, I will get an error right away. Where is this error? Up here. You see, cannot make a static reference to the non-static method from type from inside the class recursive fib. Okay, so please don't forget that. So I will go back here and add my static keyword again. Okay, so far is everyone's following? So far everyone's following? Okay, perfect. Now, how does the method look like? Very simple and very easy, as we explained yesterday. I know that the fib of n is equal to 1 and the fib of 1 is again equal to 1. So the method now takes a parameter, an input parameter called n of type integer, and it returns a result of type long. Okay? So if n is less than or equal to 2, then please return 1. Here we go. Else, keep calling the fib, else return fib n minus 1 plus fib n minus 2. Okay, fib n minus 1 plus fib n minus 2. Now I can run my by the way, is the method clear for everyone? The recursive method. We have explained it yesterday. Is anyone still confused? So I guess it is clear for everyone, right? Clear? Please mark this, everyone. Okay, perfect. Right. Now, how does the program again run? Here we go. Okay. If I enter the value 6, you see, so fib 1 is equal to 1, fib 2 is equal to 1, 3 is equal to 2, until fib 6 is equal to 8. Now, what about if I run this program for 50 numbers, for instance, like that? Here 50. So I need the fib from 1 up till fib 50. Here we go. Now I need you to focus a bit. You see the output is becoming slow. In the beginning it's very fast. Now it's getting slower and slower and slower. Okay? So you see, it's taking time. And I will stop my program now. Okay. Why is it taking time? I need to see where is the problem. So to see where the problem is, we can try to trace our code manually. We can trace our code manually. How can we do that? Okay. Whenever I call the fib method, I need to know which numbers are for which numbers is the fib as also calculated. So for instance here, if I'm passing the value of 6, okay, then I know that 6 will be this condition will not be satisfied, so it will not return a 1. However, it will return fib 5 plus fib 4. Now when fib 5 is called, okay, which fib will be again called? So it will call fib 3, fib 4 plus fib 3, and here it will call fib 3 plus fib 2, etc. Okay, so I need to see that with my own eyes by putting some print statements within the code so I can see it. Okay, so how do we do that? I will do just a couple of modifications. Now, instead of having the fib for a group of numbers, I just need it now for one number. So instead of having this loop, so no loop now, just no loop now, so I will just here, and the n will be just only the number for which I get the Fibonacci, okay? We want the input to be very simple in order to be able to trace it. So here. So if the user enters, for instance, 6, I will just call the fib method for the value 6, and that's it. Okay? And then when I print it, it will print fib n and give me the result. Okay? Is this clear, everyone? So I will just get the result for only one number, not for a group of numbers. Now, and when calling here this method, I will do a couple of changes. Now, so far, I know that if n equals 2 or 1, it will return 1. If else, it will return the fib. It will call the method fib n minus 1 plus fib n minus 2. Okay? But I need a couple of things. So I will say here, once the number, once the fib method is called, I need to see which number is the fib is the Fibonacci method calculated for. So just after calling the fib, the first thing that will be printed, which fib n are we looking for now? So entering fib n plus n. Okay, so this will show me which number am I calculating the Fibonacci for. Then I will here create a variable called long f, okay? And instead of saying return right away, I will just say f equals 1, okay? And here I will say f equals fib n plus fib 2, okay? And in the very big end, I will just return f. It's the same exactly, but I need the f value, okay? I need to print it before I return it. So now I can just easily print it by saying the following. System.out.print line existing fib and the return value. So you see what I'm doing here actually? Once a number is entered, I'm saying right now we are calculating the Fibonacci for number whatever, okay? Then when we call the fib method in recursively here, after it's called, I will print, okay, the existing fib now, which one is being calculated, which number for which is being calculated n, and the return value, which is f. Okay, now let's see how the program runs now. You see, this is exactly what we did with the tree here. If you remember it, we have drawn a tree yesterday. This tree. When I enter fib 6, I know that this is translated into fib 5 and fib 4. Fib 5 is translated into fib 4 and fib 3. So this is what I want to see here in my code. So here we go. I will run it now. So again, it will give me enter n. Now I'm giving the number, only one number for which the fib is calculated, so 6. And here we go. Now, you see where the result is? Fib 6 equals 8. But in order to reach the fib 6, which is equal to 8, we have done what? Here we go. In the beginning, I'm tracing now the code with you. When I called here, just a second, right now I'm in the main method. I entered the 6. And then it has been, the fib method has been called, okay? The print, now we will not print anything because now we're going to call the fib method. So this statement of printing is now delayed until I get the result, which will be stored here in f. So now where are we? I'm calling the fib method. So fib 6. Okay, when I call fib 6, so n is equal to what here? It is equal to 6. So system.out.print line entering fib n equals to 6. Here we are. Everyone's following so far? Everyone's following so far? Okay, then I will continue. Long f. If n, I know that n is equal to 6 now, so if n less than or equal to, then f equals 1. In my case, this is not true, else f equals fib n minus 1, so I'm calling again the fib plus fib n minus 2. So if I'm calling now the fib, what will happen? Okay, you see what will happen? Fib n minus 1, so it will go back here and call the fib. Will this statement be executed, the system.out.print an existing fib? Or I shall first finish the fib method here that's being called. So again, will be the system.out.print line here, this statement, be executed? Or I need first to, yes, exactly. This is dalal. What about the rest? Yes, exactly. Why? Because I told you yesterday, the Java runtime, whenever I'm calling an instruction, it has to finish this instruction completely until it goes to the next one. So if I'm saying here go and call the fib method, so it will call it and will not execute this statement. So now I'm calling fib n minus 1, so it will go here and call fib n minus 1, which is now what? n5. So system.out.print line entering fib n what? 5. Here we go. So entering fib n equals 5. Okay? And then what about here? This one plus fib n minus 2. So it will go here and call the fib method again, and it will write entering fib n 6 minus 2 is equal to 4. So entering fib n 4. Alright? Now, when I call the, so here I'm calling the 5 and the 4, you see? Then in entering fib n equals 3, so it goes line by line, so it keeps calling the fib, and it keeps saying what fib am I calling for, etc. Once the 2 is reached, or the 1 is reached, a value is returned, which is 1. You see? Once a 2 is reached or a 1 is reached, now so this method, this one will not be executed, and I will go to this statement and a value will be returned, which is 1. Here we go. 1 existing fib n equals 2, return value equals 1, and the same happens for the rest. But as you can see here, you see how many steps do we go through until we reach our own value that we need, which is the fib. 6 equals 8. Okay, so now the conclusion here is that although the recursive method is very useful, however, it sometimes takes a longer time than its counterpart, which is the loop. We said, or we agreed yesterday, that every recursive method can also be translated into a loop. Okay, let's see the same example. If we do it, you remember when I wanted here, I will give you here also another value. What about n50 here? You see, it will take endless time. It will keep running and running and running. It will take lots of time. Okay, so I will stop it right now because we don't have time to wait for the output. And I will go now and create the same example or calculate the Fibonacci value, but now using a loop. Okay, and here it is. Now let's see how it looks like. Again, it's the same start as we explained in the recursive fib. Here we read the value that the user is entering. In this case, the user is entering what? The user is entering again a group of numbers for which he wants to know the Fibonacci results. So system.out.scanner equals new scanner. Then system.out.print line enter n. Okay, and then I'm going to use the method next int from the object in, which is of type scanner. The value that will be entered by the user is received in n or stored in n, which is of type integer. Again, I will have my loop, okay, for each number until I reach n, and then I will call the fib method, and the result will be stored in f. That's it. Now, how does the fib method now look like? The fib method now, that it's not a recursive method anymore, but it is a loop. Okay, let's explain it. I know again for sure that if n is less than or equal to 2, then return 1. So this is, we have already agreed upon. So this is okay. Now, we also know that the Fibonacci of any number is what? Is the Fibonacci of, so the Fibonacci of any number n is the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. Okay, so I will call n minus 2 the older value. So this is as if it is, here I will do a comment here, n minus 2. And the n minus 1 is called old value. So I have an older one and I have an old one. Okay? And the new value is the new result of, is the value or the final value of the Fibonacci result. Okay? So here we go. Now I will have a loop. Again, the loop will start here from 3. Why from 3? Any clue, girls? Why from 3? Why do we start int I equals 3, not from 1, not from 0? Yes, Dalal? Because 1 and 2 have the same value equal 1. Exactly that. Yes, Umniya, this is the answer of Umniya. Dalal, I couldn't, we don't have to calculate. Yes, exactly. Same answer. Okay, well done. Because already it is, we have already considered the values of n equals 1 and 2. So, and it will return 1. So after that, we have to see what will happen. So we'll start from int I equals 3. I keep running until you reach what? Until you reach n. And then I plus plus. Okay, so I know here, now the new value is equal to what? The new value is equal the old value plus the older value. Can we do an example here? Let's do the fib6, for instance. No, fib6 is too long for us now. Let's do, for instance, the fib4. Fib4 is fine. If I want to calculate the fib4, what will happen? Okay, fib4 is actually equal to what? If I will, I can here have a loop here now. So if 4 is now 2 is less than or equal to, it will return 1. So no, this is not my case here. So in case of now n is equal to 4. Okay. Now I go here. Int I equals 3 and I less than or equal n and I plus plus. So what will happen? The first result, I know that old value is equal to 1 and the new and the older value is also equal to 1. So once I go in, I is equal to 3, I less than or equal to n and I plus plus. So I'm now in iteration 3. What is the value of the new value? It's equal to 1 plus what? Plus 1. So here it's equal to 2. Okay? Now, the older value will take the value now of whom? Of the old value, which is the, so as if we are saying, now the older value, which is the n minus 2, will shift to the right, okay? And will take the value of what? Of the old value. So now, the older value is equal to 1 again, because we haven't changed this, okay? What about the old value? Again, as if we are shifting it to the right again. So old value equals now the new value, which is 2. Now please make another iteration. I plus plus. I plus plus means that I is equal now to 4. So we can still, 4 is less than or equal to 4. Yes. So keep running. Okay. The new value is now what? The new value is old value plus older value, which is, what was the last value for old value? The last value for old value, it was 2. And what about the older value? It is 1. So now 2 plus 1 is equal to 3. Okay? And we go now here. what is the value of older value? Older value is equal to old value, which was here in the last iteration 2. Okay, and then what is now the value of old value? It is the new value, which is the 3, and so on and so forth. Now keep iterating. I plus plus the 4 is less than or equal to 5, so you have to stop, and then we return the new value. What is the return of the new value? Here, this is the last value for it. This is the 3. Okay, I'm trying to trace it with you orally to make you understand how the loop works. Okay, USA. Yes, exactly, girls. Fib3 plus Fib2, yes. So now the value is, if we calculate it, again, now if I want to run my program here, and I will tell it, please get me the fib for the first 6 results. Okay, we are not in the loop. We are not here. Just a second. Okay, 6. So fib1 is equal to 1, fib2, fib3, and fib4 is equal to 3. Here we are. Okay, so this is how it's being calculated using the loop. So as if it's saying what? As if it's saying, take always the value from the n minus 1 and the n minus 2, and then sum them up, and you will have the new fib. If you go to the other fib, I mean, if you go to have, if you want to calculate the fib result of a larger number, then take the last value, which is the old value, and the one before, which is the older value, and then sum them up again, and you will get the new result. And that's it. Okay? So is everyone following so far? Is everyone following so far? Okay, perfect. Now, I want to show you a very nice thing now. If I run the program again, and I will tell the program, please get me the fib for the first 50 numbers. Here we go. You see what happens? It's very fast. So from fib 1 up to fib 50, it just calculated it in 1 second. While when we use the recursive method, it got slower and slower and slower. Alright? So now the criteria here, when thinking recursively, first thing you have to consider is, will be the recursive method more efficient than using a loop, or vice versa? Okay? So here we go. In my PowerPoint, the efficiency of recursion. Methods take so long because, just a second, because we have, here we go. Method takes so long because it computes the same values over and over. Okay. Also, a recursive solution usually, occasionally, not always, a recursive solution runs much slower than its iterative counterpart. When we say iterative counterpart, this means a loop. Okay, these are some theoretical, but however important notes that you might be asked about in the exam. So you need, now you understand why, okay? For instance, in the case of fib, because the fib is being called over and over and over. In the case of loop, no, it will be calculated on the spot. Okay. In most cases, the recursive solution is only slightly slower. So in most cases, the recursive solution is very close to the iterative counterpart in terms of efficiency. Okay. This method, which is Palindrome, we haven't demonstrated yet. Okay. Okay, it's important for you that some compilers are very smart and they can avoid recursive methods calls if they follow simple patterns. However, most compilers don't do that. And in many cases, the recursive solution is easier to understand and implement correctly than an iterative solution. This is true because when we explained the, I think when we explained the recursive method using to calculate the Fibonacci, it was very easy. For the loop, it's not complex, it's easy, but it's not as straightforward as the recursive method. So although the recursive solution can be easier to understand, sometimes or occasionally it is a bit slower or much slower than the iterative loop. Okay? That's it. So, is it clear for everyone so far? Is it clear for everyone? Okay, perfect. Now we have another example. Okay, in this chapter, girls, you have to know the following. It keeps giving you some many examples about iterative methods. For instance, like the factorial method, like you can use it or you can calculate it using recursion as well. It gives you an example about the palindrome method. Okay, I will explain it right now. About expressions. Okay, so it's just a matter of examples, but most important, you understand the concept right now. Now we have now only left 15 minutes. Okay, I don't think we will have the time to go into writing the code of the palindrome. However, we can just explain what is palindrome, and then I will tell you what we can do. Maybe we can have, I will not organize an extra session. I will just have a recorded session for you that explains the code of a couple of other methods that can be implemented using recursion. Do we agree on that? Do we agree on that? Okay, perfect. Now I will go now to the palindrome here. Okay. What is palindrome? The problem is when you state first the problem, you need, if you have any sentence or any string text, you want to test if this sentence or string text is palindrome. Now the question is, what is palindrome? A palindrome is any string, okay, that is equal to itself if you reverse all characters. In other terms, if I have a couple of characters in or some text, okay, and then I reverse the characters of this word, okay, I might have another word. I might get another word. Okay, does this mean that I need to reverse all characters or actually use all characters? Not necessarily, but most important that either all characters or part of these characters, if I reverse them, I will get a new word. Let me give you an example. Here, for instance, this one is very nice. This is the most famous one. Madam is actually a palindrome of I'm Adam. Why? You see what happened? Madam, if I go now reverse, madam here. So if I now separate this, okay, this is what, if I read it from right to left, so this is Adam, right? And what about the M? M is separately, and if I add the I to it, so it will be called I'm Adam. Is this clear? Is this clear? Okay. Another nice example is the one above. Here. Go hang a salami. Is this text or is this sentence a palindrome? This is a question. Go hang a salami. Okay. Now, if I separate it like that, I'm, okay, here I'm going now from right to left. I'm you see, la lasagna. Here we go. And I will concatenate this to this. I'm a lasagna hog. You see what I'm doing? I'm reading from right to left. So, I'm a lasagna hog. Here we go. I'm a lasagna hog. So this is what happened. It is a palindrome. We just read the sentence or reverse the characters, and we got a new sentence or a new word. Same wise for man. A man, a plan. Okay? A canal, they all give me Panama. How is that? Man here is the same characters as man reversed here. You see? You see the man here, but it is reversed. Same for canal, but but we will actually same for canal here. But ignore the C and ignore the L, and you will see something called Anna here. The Anna is presented here as well in the canal, but reversed. Okay? The plan, remove the L here, this way. It's called pan, and I will see something called nap here. You see? I will return it as it is. Now, is this clear? Is palindrome clear for everyone? It's a simple, yes, it's a simple technique. If you Google it in and you just write palindrome, it will give you the same examples. So there's something popular in English as well. Okay, or you can use it with string tests, or you can use it actually with symbols or whatever you want. Now, can we solve this problem in Java? If I take any string and then I'm asked to say if this string is palindrome or not, yes, we can do that. How is that? By using, again, recursive methods. And this is how we can do it here. Okay. Now, we agreed that in order to think about any problem, we need to find a solution for this problem, or actually we need to find the simplest solution for this problem and start thinking recursively. How do we do that? Okay, we'll take it step by step, and this way you learn how to think recursively. These are the several possibilities that we have in order to determine or to decide if this word or sentence is palindrome. First, we remove the first character, and then we check. Then we remove the last character, and then we check. Then we remove both the first and last characters, and we check. Then we remove a character from the middle, as we did, for instance, with plan, and it ended up with pan, which is existing already in Panama. And then we also can cut the string into two halves, etc. Okay? Another thing, as we mentioned, combine solutions with simpler inputs into a solution of the original problem. Okay? So, for instance, if I remove the first and last characters, like this one, you remember this was Madam here, and this was I'm Adam. If I remove the M from here, so which is the last character here, and the first character in this one, I will see something called Adam, and I'm Ada, and again, the Ada here is already included in here this way. Ada, okay? So this is a palindrome. So condition 1, if I remove the first and the last character from the string, and still it is similar, or then it is a palindrome. Okay, thus, if the first and last letters match, M and M, as we did here, and the word obtained by removing the first and last letter is palindrome. So this is one condition. What else? I might face a situation where the first letter or first character actually in my word is not a character, is not a letter. It might be a question mark, it might be a symbol, it might be a number. So in that case, I have to ignore it. So if the first and last characters are letters, check whether they match. If so, remove both and test the shorter string. You see what's going on here? I'm going step by step with the word. Here we go again. Madam and Adam. First thing to do is to do what? Remove this M and remove this M. Now test the shorter string. Now I have A and A again, so first and last characters, again they match. You see what's going on, girls? First and last characters, they match. Okay. Then test the shorter string, which is damn, and I'm add. Again, the first, which is the D here, and the D here, again they match. Okay. Now test the shorter string, which is the A and the A. Okay, this is very nice here. So M and I'm M. So what about the first character and last character here? I have here M and M. Alright? So again, they match. So this character or this word is palindrome. Now, I still have a couple of things. I still have here a comma, I still have I, and I still have a quotation here. Now, if the character you are checking is not a letter, so in this case it's a comma, so I will remove it. And here it's a quotation, so I will remove it and I will not do any check. What is left? What is left now? The letter I. Is I palindrome of I? Yes, exactly. Any character is a palindrome of itself, so I can be again reversed to I, of course. So you see what happened here? I kept removing first and last characters until I reached the if they do match. Then I started checking the following string, the shorter string, etc., until I reached the one character, and a character is palindrome of itself, of course. So I will decide here that this, or I will return here that this string is palindrome. Okay. However, there are a couple of conditions. So if the first and last characters, and this is what we have just explained. If the first and last characters are letters, then check whether they match. If so, then remove both and test the shorter string. Now, if the last character isn't a letter, then remove it and test again. If the first character is not a letter, so it's a symbol or whatever, then remove it and test again. And that's it. Find solutions to the simplest inputs, so strings with 2 characters. Okay, this is good, perfect. I will compare them. We will continue checking. If the string with a single character, then here we have reached a solution. They are palindromes. If it is an empty string, then of course it is a palindrome as well. Okay, you see what happened here? We kept dividing the problem into smaller problems until we can find a simple solution, and then we will start thinking recursively. I think after this explanation we will be able easily to implement it, right? Okay, as I agreed with you, I think as I agreed with you, I will run a recorded session for you to show you how we implement the palindrome method. It's very easy after this explanation. And also there are a couple of other recursive methods that I will include. And please, what I need you to do now is to read the recursive methods, okay, that are included in your chapter, everything. Try on your own to write the code, okay, and then also listen to the recorded session, and by that we will be done with the chapter recursion. I will stop recording now.
Recording stopped.